Today's topic is right triangle trigonometry, something that you should all be familiar with. It's dealt with in your geometry and a little bit in your Algebra 1 class, so this shouldn't be so bad. Right triangle trigonometry. Of course, the important thing is that we deal with a right triangle. Here we'll typically talk about one of the acute angles, let's call it angle A, and then the trigonometric ratios, of course meaning fraction. The trigonometric ratios will compare sides. So if we look at angle A, this side would be called the opposite side, opposite A. Here this side is called the adjacent, meaning next to. Of course this side is next to, but we'll always refer to the longest side or opposite the right angle as the hypotenuse. So our trig ratios, there's three different trig ratios that we're going to deal with. There is the sine, which we'll abbreviate with SIN. This relates the opposite side to the hypotenuse. There is the tangent. We'll always relate the opposite side to the adjacent side. And then last but not least is the cosine. And that will relate the adjacent side to the hypotenuse. So that's why they're called ratios, is because they compare two sides given one angle. There are your trig ratios. One term that they're all often going to use in your textbook is the word bearing. So just to know the word bearing, if we consider this being the north direction, here you can see that we set up east, south, west. We set up a axis, an XY axis. The bearing is always the measure off of north. So if I have this angle right here, if this is 60 degrees, this is a bearing of 60 degrees. So it's always the measure off of north. So a bearing of 120 degrees is going to be the measure off of north, coming down here where this angle measures 120 degrees. Well, that's going to be it for notes. What we can now look at is a couple example problems here. Let's set up a problem like this. Having a right triangle, symbol here meaning right angle, of course. If we know, if we're going to call this side A, lowercase typically used for side, this is 32 degrees. This side is 14.7. And if we want to solve for side A, now given it's a right triangle, we can use our trigonometric ratios, these three. So to determine A, first I look at this angle. Angle 32, this side relates to the angle 32. Well, it's the longest side opposite the 90. This is the hypotenuse. Now the side right here, from 32 degrees, we look at the side that it relates to here, this 14.7 is the adjacent side. So then we look at it, the information we want to find, the information that we know, and then we make a comparison to our trig ratios. I know the adjacent side and hypotenuse. Well, that's obviously adjacent hypotenuse is going to be cosine. So we can use the cosine of my angle, relates my adjacent side to my hypotenuse, the trig ratio. So in this, writing the formula down, the cosine angle A in this case is 32 degrees. The adjacent side is 14.7. The hypotenuse is A. So here we have something where we have the cosine trig ratio, that the only variable, the only unknown is A. To solve for A, well, first of all, A is in the denominator, so it's divided by A. Little algebra tells us to multiply A to both sides, so that we remove the A. A over A is 1. We have A times the cosine of 32 degrees equals 14.7. And then still, to solve for A times the cosine of 32 degrees. To get rid of multiply, we're going to use the inverse, which is divide by the cosine of 32, both sides, to maintain the balance. The cosine of 32 over the cosine of 32 is that very special number 1. So therefore, A equals 14.7 divided by the cosine of 32 degrees. And then here, little calculator work, and you should get that A is approximately 17.3. So there we have our trig ratios, all related with right triangles, comparing the different sides of the triangle. We have 3 trig ratios that each deal with ratio, meaning fraction. Here we have it set up like, here we have set up for an example problem to practice with.